When we want to indicate just how acidic or basic a solution is, we can use a value called pH. It stands for potential of hydrogen, but pH is a scale used to relate the strengths of acidic and basic solutions. And the pH range will go from 0 to 14. Sometimes you'll see pH scales going from 1 to 14, but most of them probably start with 0. And smack dab in the middle, with a pH value of 7, is where we have neutral solutions. Pure water was going to be a neutral solution. And in those solutions, the number of hydroxide ions are completely equal to the number of hydrogen ions. But if we start to have more hydrogen ions than hydroxide, whenever the hydrogen ion concentration, that's what it means when it's in brackets like this, is greater than the hydroxide ion concentration, then you will have an acidic solution. And the greater the number of hydrogen ions you have, the more acidic it'll be, the closer to 0 on your pH scale. On the other hand, if you start to have more hydroxide ions than hydrogen, then you will start to have a more basic or alkaline solution. Alkaline is another way of describing a basic solution. So whenever we look at different pH tables, you can see this one goes from top to bottom. pH value of 0 would be like hydrochloric acid. You get a little bit more, you get stomach and acid and lemon juice, vinegar, cola, beer, tomatoes, coffee, rainwater, urine, saliva. All of those are acidic. These are only slightly acidic. These are very acidic. And if you look at the picture here, it shows you that there are a lot more of these H pluses than we have of OH minus. A lot more hydrogen ions than hydroxide ions. At 7, you have a neutral solution here. Pure water has equal amounts of H and OH. And then as we move further down the pH scale, we're going to have more and more hydroxide ions. Until we get down here, you see that there's a lot more OH groups than there are just hydrogens. So seawater is slightly basic. Baking soda is a little bit more. Milk of magnesia, it's a medicine used for heartburn, things like that. Household ammonia, bleach. We're getting very, very strong bases here. Oven cleaner and sodium hydroxide. Those are all basic whenever you get past 7 on our pH scale. This is another way of looking at it, so you can kind of see that whenever it's neutral, when the pH value is 7, we have equal amounts of our H plus and OH minus. Hydrogen and hydroxide ion concentrations are equal. But as we go back closer to 0, at this point when pH is 4, you can see that we still do have some hydroxides, but there's a lot more hydrogens here at that pH value. And then when we get all the way down here to 0, okay, you can see that there still might be a tiny, tiny infinitesimal amount, but the majority of the ions present are going to be your hydrogen ions. When you head back the other way at a pH value of 10, you can see that the majority of the ions are going to be OH, but we are still going to have some hydrogen. And when you get all the way up here to 14, you might have a tiny bit of H plus up there, but almost all of it is going to be hydroxide. This chart is just kind of a different way to look at it. You have the hydrogen ion concentration represented by the red here, or the orange salmon color. This is the hydrogen. And then the blue is representing the hydroxide. So on the acidic side, on the far left, you see that you're going to have a lot more hydrogen ions. It's also sometimes shown as hydronium, which is H3O+. That's another way of kind of thinking about it. And you're going to have all of your acidic substances up until you get to neutral. At neutral, you have a certain amount of hydroxide ions, and then you have equal amounts of your hydrogen ions there in the middle. You put the parts together and they would both be equal. Back on the acidic side, we only had one little dot here in the center for hydroxide. When we get neutral, we've got a pretty equal amount. And then when we get to the far basic side, we've just got that one lone hydrogen ion shown there. The majority of it will be the hydroxide ions, the OH minus. And it has some characteristics. Our bases, remember, taste bitter. They feel soapy or slippery. Our acids, on the other hand, are going to be sour. And you can kind of see some different pH values of some common substances there. So the way that we would determine pH if we were using a calculator would be to take that hydrogen ion concentration, you take the log of that value, and it would give you a negative number. So then you take the additive inverse, you take the negative of it, and you end up with the pH value. Now, for what we're working with, we're only going to have hydrogen ion concentrations that are reported in this manner. 1 times 10 to the something power. And a short way of finding the pH when you're given that hydrogen ion concentration is take that exponent, remove the negative sign, and that is the pH. That's what would happen if you took the negative log of that number. So in order for us to use that approach with this number, we have to put it into scientific notation first. So if this was 1 times 10, okay, that means our decimal is here after the 1. Go ahead and if we move our decimal back, we move back 1, 2, 3, 4, 5, 6 times to get it back where it belongs. So that would be 1 times 10 to the negative 6th. So we take our exponent, we take the negative off of it, and that is the pH. And then we use that pH to figure out, is it acidic, is it basic, or is it neutral? If the pH value is 3, that means that it's less than 7. 7 is where it splits here. This is acidic. This is basic. So if it's less than 7, it's acidic. So both of these solutions would be acidic in nature. The first one's more acidic, but they are both acids. So let's go backwards. If we want to find the hydrogen ion concentration of something with a pH of 9, we have 1 times 10, and then we take our pH and we put it as a negative as our exponent. And we look at the pH to find out what type of solution. Since it's greater than 7, it's going to put it in the basic range. We can also describe solutions using something called a pOH value, or the potential of hydroxide. It's figured out in a very similar fashion, but one of the things we can use to help us find it is the fact that the pH and the pOH add together to equal 14. So if I know the pH, I just subtract it from 14, and that'll be my pOH. So on this first one, we have hydroxide OH concentration, and it's 1 times 10 to the negative 4. So if we want the pOH, we take that number, we take the negative off of it, and the pOH is 4. So if the pOH is 4, what does the pH have to be in order to make that statement be true? We take away 4 from both sides, the pH has to be 10. So we use pH to figure out what type of solution it is. If the pH is 10, it's greater than 7, so it's basic. If pH is 6, what is the hydrogen ion concentration? So make sure these match. That's H, that's H. So it's 1 times 10 to the negative 6. And I can go ahead and figure out if it's acidic or basic. They tell me the pH is 6. That's less than 7, so it's going to be acidic. Now, we can go about this next one a couple of ways. If we know the pH is 6, we know that 6 plus a something has to equal 14. That something is our missing pOH value. So that would have to be 8. 8 plus 6 will get us 14. So that means that the hydroxide ion concentration, that's OH, would be 1 times 10 to the negative 8. You'll notice, though, also that this number and this number add up to equal negative 14. So we can kind of skip over this step over here of finding the POH if we just figure out what number combined with this -6 would give me -14 once I add them together. Okay, if pH is 5, it's less than 7, it will be acidic. What is the hydroxide ion concentration? So the first thing you need to be checking is if these things match, and they don't. So that means that we can't use pH. We have to figure out what POH is. So remember, the two numbers have to add up to equal 14. So 14 minus 5, we're left with 9. And then we'll use that to figure out the hydroxide ion concentration, 10 to the -9. Okay. If the hydrogen ion concentration is 1 times 10 to the -2, that means that pH is 2. We want to know POH. So 2 plus what number will give us 14? So we're doing 14 minus 2, we're left with 12. And think about which number we need to think about to see if it's acidic, basic, or neutral. And what we're concerned with is pH. So the pH was 2, that's less than 7, so we know it's going to be acidic. So I'll help you get started on the assignment. You're going to be completing a table. And just be sure that whenever you're trying to figure out if it's acidic, basic, or neutral, you always look at pH. We're looking at this column over here. Okay, so the first one's done for us. So if you need a worked out example, you can always refer back to that first one. These first two are kind of grouped together. So if the pH was 5, then our hydrogen ion concentration was 10 to the -5. So if our pH is 7, then hydrogen ion concentration is going to be 10 to the -7 molar. Remember, we put the M underlined to represent the concentration. So then if we know pH, we can find POH because pH and POH add together to equal 14. So 14 minus 7 leaves us with a POH of 7. These two go together. If the POH is 7, then the hydroxide ion concentration is 10 to the -7. And then we look at the pH over here to see if it's acidic, basic, or neutral. And whenever it's neutral, it's at that value of 7. Okay. So for the next one here, our hydroxide ion concentration is given as 10 to the -4th. So we can get POH as 4. And we know that that plus pH equals 14. So 14 minus 4 leaves us with 10. So the hydrogen ion concentration is 10 to the -10th. So think about what are we going to look at to figure out what type of solution we have. We're going to look at pH. If pH is 10, it's greater than 7, and it's going to be basic. So you have one of each type here to look at. There's a few left to work through.